another episode of today's lecture in general biology. Today we'll be looking at factors affecting enzyme activity. In the previous videos, we've talked about enzymes, we've talked about the characteristics or properties of enzymes. We've also looked at the classification of enzymes. And today we'll be looking at factors affecting enzyme activity. Normally, enzymes are usually their activities are usually being facilitated or impeded by certain factors. And that is what we'll be looking at on today's video, on today's lecture. So the first factor to be considered here is is temperature. It is important to note that the activity of an enzyme can be highly influenced by the temperature surrounding that particular area in which that enzyme is acting. And now, the increase in temperature, as an elevated temperature, tends to increase the activity of the enzyme up to a point which is regarded as the optimum temperature. Optimum temperature. Now, this optimum temperature is the temperature at which the enzyme's activity is in its highest efficiency. Now, anything beyond that temperature tends to lead to what is referred to as denaturation. Denaturation is actually a term used to describe the loss of an enzyme's active state. You know, enzymes are proteins, right? And proteins can be denatured. So once the optimum temperature for an enzyme is being exceeded, it means that that enzyme could lose its native state, which is referred to as denaturation. So it is important to understand how enzymes work. There are certain enzymes that operate at certain temperatures. So if you exceed that temperature, the activity of that enzyme is going to retard, or is going to decline. That's why if you look at this curve I'm going to draw now, it's just a simple graphical illustration. This is temperature. And then this is increase in enzyme activity. Let's say we have these data as 2, 4, 6, 8, and then 10. And now, the activity of the enzyme, let's say, starts from here. Right? Increase in temperature means that there will be increased enzyme activity. Hence, it goes this way, right? And it gets to a point, this point, where this point is known as the optimum temperature. This point is known as the optimum temperature. Optimum temperature. Now, if the activity of the enzyme gets to this point and it is further increased, there will be a decline. That decline now means that the activity of the enzyme begins to drop. It drops until it elapses. That is how this curve works. So basically, there are certain enzymes that have different optimum pH. So depending on what you're working with. So it is important to note that the one of the factors that can affect the activity of an enzyme is temperature. Increase in enzyme activity can be influenced by temperature. That means you can increase the temperature of a particular area you're working with respect to an enzyme. It gets to an optimum temperature where the enzyme's activity becomes highest, and then over time it drops, leading to a decline. So this is the first factor, or the first factor that I am considering that affects enzyme activity. Another important factor that I'll be looking at is pH. pH. You know, in the other video, while I was talking about the characteristics of enzymes, I did mention that they are pH specific, right? I did mention that. Now, increase in the pH level of a particular enzyme, of a particular substrate rather, can also influence the activity of that enzyme. Now, most enzymes act very well on acidic environment, right? While some act very well on alkaline environment. So you have to understand the pH level, or you have to understand the pH system of an enzyme you're working with. So that is why enzymes are being affected by pH. Now, they also have the same curve as the temperature. It starts from, let me just simply draw this here. This is just a schematic representation. There is no data. I'm not using any defined data for this. I'm just trying to illustrate what I said. So basically, it starts from a point, right? Moves, increase, and then it gets to a point where the activity of that enzyme becomes highest. That is what is referred to as the optimum pH. In this case now, I'm using these points. Pardon my drawing. I'm using this point, and then it declines over time. So we call this the optimum pH. Right. So that is it. Basically, temperature and pH have the same curve pattern. The third factor that I'm looking at that influences or affects enzymes activity is substrate concentration. Now, increase in the substrate level of a particular reaction can highly influence the enzyme's activity. Now, if you increase the rate at which a substrate is being, the enzyme acts on a substrate. So now, if you have much substrate, it means you need more enzymes that will take up those substrates. Now, the enzyme will act on the available substrates, right? Such that when it is being saturated, it can no longer do any much work. That is why if you look at the curve for substrate concentration, it goes this way. it goes this way. It goes this way, where this is the point where the enzyme has fully saturated the substrate, and then it starts to decline this way. It doesn't go downwards, because you know, when an enzyme binds to a substrate, it leads to an enzyme substrate complex that in turn leads to a product. So now, if I have, let's say, for instance, I have 10, let's say for instance, I have 10 substrates, right? It means I need 10 enzymes. It means I need 10 enzymes that will act on these 10 substrates. If I increase the number of substrates here now, let's say I increase it to 20 against this 10, it means I need an additional 10 substrate, an additional 10 enzyme that will act on the newly added 10 substrates, right? So that is simply telling us that the more you increase the substrate concentration, the more enzyme substrate complex is being formed. So now, if the enzyme is saturated, it means there won't be more products formed. The substrates will just be there, uncatalyzed by any enzyme. That is the third factor affecting enzyme activity. And another one we'll be looking at is the fourth one, which is enzyme concentration. Enzyme concentration is quite similar to the substrate concentration. Increase in the enzyme activity is being favored by more enzymes against a substrate. That means if the number of enzymes increases, it means I have more substrates that the enzyme needs to be bound to. And remember, we said enzymes are very, very specific in action. That means for one substrate, we have a corresponding enzyme. For one substrate available, we have a corresponding enzyme that is bound to it, right? So that is it. It means if I have less amount of enzyme in a particular confinement and I have more substrate, it means product formation is being limited in that particular area. So this is just it. It is very, very simple to understand. So the fifth factor that we'll be looking at that affects enzyme activity is presence of inhibitors / activators. Right? Now, these two components have a way of influencing or affecting an enzyme's activity. Mind you, an enzyme can increase the rate of a reaction or it can slow down the rate of a reaction depending on the component. Now, for inhibitors, what they do is that they come into the picture to reduce or decrease the activity of the enzyme because they tend to bind to the substrate. You know, they bind to the substrates. Now, if an inhibitor binds to a substrate, It means the enzyme can no longer bind to it. That's in the case of competitive inhibition, because now in the case of competitive inhibition, we have that the inhibitor and the enzyme are the inhibitor and the substrate rather are struggling for the active site of the enzyme. Now, if I have more inhibitors binding to an enzyme, it means I will have more enzyme inhibitor complex than more enzyme substrate complex in the case of a competitive inhibition. In inhibition, we can have competitive inhibition, we can have uncompetitive inhibition, and we can have non-competitive. Now, depending on the type of inhibition, we'll now know what is going to be the fate of the enzyme. Because in every enzyme, an enzyme have what is known as the active site. Every enzyme has an active site, which is made up of amino acid residues. Now, this active site is the catalytic site of every enzyme. This is where the substrate binds to. It is also where the inhibitor will bind to. Now, if for instance we have in a particular, let's say in an enzyme's active site, we have more inhibitors coming in. It means the action of the will have less substrate coming in, because the inhibitor and the substrate cannot be there at the same time in the case of competitive inhibition. Now the enzyme also has another site known as the allosteric site, but we're not going to be talking about this in depth because it is going to be out of the scope of your work. But for now, just know that where the inhibitor or the substrate will be binding to is the active site of the enzyme. Now, these inhibitors, when they come into the active site of the enzyme, they tend to decrease its activities. And then for activators, they tend to elevate or increase the enzyme's activity. So everything I've said, from temperature to pH to substrate concentration to enzyme concentration down to the presence of inhibitors and activators, are the factors that affect enzyme activities. Sometimes you can be asked in your exam, you say, which of the following affects enzyme activities? And then you see any of these things we've talked about, just know that it is the answer. If they say which of the following does not affect enzyme activity, if you don't see any of these things there, if you see if you don't see any of them there, just know that that's not what they are talking about. So this is going to be the end of this class, and I'll see you guys in the next video. Thank you and stay put.